Welcome to the session. So we were discussing about storage structure, secondary storage structure, in which we have stopped in our last session in this disk scheduling. So there are three sources of disk IO request: operating system, system process, and users process. And we have seen about the different based on the different request, IO request, and which may include input or output. So based on that, the disk may be allotted. So for this particular reason, we have the scheduling algorithm, so that based on the request, the disk space is allocated. Disks are allocated. So now we have different algorithms for this disk scheduling. So we will see in detail about this particular disk scheduling algorithm. So we'll move further. The first algorithm, FCFS, first come first serve algorithm. So in this first come first serve, as the name says, based on the request has appeared in the list, based on the request, the disk, based on the IO request, the disk has been scheduled. So now consider the situation. So we'll go through with the example so that you can easily understand. So we have a queue with the 98, 183, 37, 122, 14, 124, 65, 61. So these are the corresponding head movements. Consider we have a 640 cylinders. So out of which, so these are the request has been appeared requesting for the disk. So these are the list of request, IO request made by the operating system or maybe the other processes. So now the job is to allocate the disks. So the disk allocation is in the form of FCFS, first come first serve, as per the name says. So according to that particular list, so first come 98 is appeared first, 183, 37, and so on. So we'll see. So now we have a situation, head starts at 53. So that means, so already the read write head of disk, which is maintained with the arm, read write arm, disk arm. So that is controlled via disk controller, right? So that is how this is what we saw in our previous session. So now the read write head is already in 53rd position, 53rd location. So now we supposed to start from this particular 53rd position. So that's why, so now we supposed to visit the queue. So according to the queue, we supposed to follow. The queue has so many entries. So these number of entries are nothing but IO request. So according to the first come first serve algorithm, so we'll check with the queue. So 98 is appeared first. So 98 is served. So we supposed to draw an arrow mark from 53rd to 98. So representing, so this particular arrow mark represents there is a movement from 53rd position to the 98. So that is a location. From 98. So after 98, we have 183 in our queue. So from 98, supposed to visit 183. From 183, we supposed to visit 37. Please follow my cursor. From 37, 122 has been visited. So you can see the 122 over here. From 122, 14 has been visited. Again coming back. After 14, we have 124 that is visited here. Then 65 and 67. 65, then again 67. So now what we supposed to concentrate using this first come first serve is based on the list entries, based on the queue entries, based on the entries in this particular queue, the head starts to move. So so consider this queue is in the form of array. If you consider as the form of array based on the index, so 98 starts from 0, 183, 1, 2, 3, 4, 5, 6, 7. So now based on that particular index, head starts from 53. From 53, the 0th index visited first. That's why 98 is visited. Next, index number 1, that is 183. Number 2, 37, and so on. So this is how first come, first serve algorithm works. Any doubts, any clarification, please get back to me. Moving further, we have another algorithm, scheduling algorithm, that is SSTF. So SSTF stands for shortest seek time first. SSTF stands for shortest seek time first, which will select the request with the minimum seek time from the current head position. It will trace out, will calculate the minimum seek time from the current head position. So based on that, it has been served. So it will, this particular scheduling form is SJF scheduling, may cause starvation of some request. On the other hand, irrespective of the queue, irrespective of the request, so it first supposed to calculate the seek time. So based on the minimum value, it has been served. So if any other request has been made, which is having highest seek time, then it has to wait. So that's why it may cause starvation for few requests. So we'll see an example. Consider shortest seek time first SSTF algorithm. So we have a queue, the same queue. So now head starts at 53. By considering 53 the head position, then try to find out which is the nearest, which is having very less seek time out of this particular request. So we have 183, 37, 128, 14, 24, 65 and 67. So now based on that, from 53, the next immediate position is 65. How to calculate seek time now? So 65 minus 53, that is 12. So that is shortest now, instead of this one 37 to 53. So 65 is visited first. Draw the arrow mark from 53 to 65. So from 65, 67 has been visited because it is the nearest. Then after 67 has to visit 37. So that is the only nearest seek time, shortest seek time. After 37, visit 14. Then 98. After that 122, 124, 183. So now one thing we supposed to observe in this shortest seek time is based on the head, or starting position, starting pointer. So by considering it as an initial point, so it will trace out all those list of IO requests from this queue, and it will list out all those having shortest seek time. So based on that, it has been allocate the disk, schedules the disk. So based on that particular reason, 53, from 53, so we are going to visit 65, then to 67. After that, 37 is scheduled. From 37, move to 14 because 14 has been served. 14 has been scheduled with the disk because it is having shortest seek time. And then 98, 122, 124, and then 183. So any clarification, any doubt, you can get back. So we have seen two scheduling algorithms. So going back once again, first come first serve. So here based on the queue list, it has been served based on the IO request which is available in the queue. It has been served from the starting position. So starting position is 53. From 53, first one, first come first serve, 98 has been served, 183 has been served, third one 37 has been served, and so on. This is first come first serve. Coming to shortest seek time first, so we have starting position, that is 53. From that we are supposed to calculate which is the nearest value, 65 and 67. So that's why 65 and 67 is visited first. Then we are going to serve 37. So that is having shortest seek time. So that is SSTF for you. Then we have scan algorithm. So this scan algorithm is also called as staircase algorithm or elevator algorithm. So because this particular algorithm works in the form of elevator or in the form of staircase. We'll see how it is. So now the disk arm starts at one end of the disk. This is the initial. So the disk arm starts at one end of the disk and moves towards the other end. Moves toward the other end, servicing request until it gets to the other end of the disk. Once it reaches end point, then the head will take a U-turn, say reverse, and servicing continues. So the disk arm should start from one end of the disk, say either from left or from the right, based on the starting point. So once if it is starts moving towards right, then it should serve all those requests, whichever it gets on that particular direction, and it will return when it reaches top end or the other entire end. So that is what we call scan algorithm or elevator algorithm or staircase algorithm. For example, if you consider as a real-time situation, consider city center in Mangalore. So around 5 to 6 floors are there. So now we are going to visit city center. So we entered ground floor. So now we are starting from the ground floor. So from the ground floor, we will visit all those shops. We will do window shopping. Then we will move on to the first floor. Again, do the window shopping. Then move to second floor. We'll do window shopping. Move to third floor. We do window shopping. Move to fifth floor, and so on. This is how staircase works or elevator works. So from 0, 1, 2, 3, 4. That is how the hierarchy. Right. So that is based on the starting position should move towards other end. Or if you take same similar situation, say you have a parking in fifth floor. So directly you visited fifth floor. So from fifth floor, based on the direction, you're supposed to move towards downwards. So then from fifth, you move to fourth, do window shopping, then move to third floor, do window shopping or do shopping, then move to second floor, do the shopping, then move to first floor. That is how the scan algorithm or elevator algorithm works. So saying that in each and every floor, we'll visit all those shops, whichever comes in that particular direction. After that, we'll move to the another floor. Then we'll check with all the shops. That is how elevator program, elevator algorithm, staircase algorithm or scan algorithm works. So one thing is if requests are uniformly dense, then the largest density at the other end of the disk, or we can say those who wait for the longest. For example, say consider the same city center as an example. Say you are already in fifth floor, you parked your vehicle in fifth floor and you entered fifth floor and you served till ground floor from fifth, fourth, third, second, first and zeroth floor. Now again you're supposed to turn back and come back to top floor. Again the same order as the staircase goes. Supposed to go to first floor, second floor, third floor, fourth floor, fifth and sixth. So now what happens is there may be largest density at the other end because there is more waiting time, waiting because of it will serve only one side at a time. That is how scan algorithm works. We'll see an example now. So we have a queue with the entries IO request 98, 183, 37, 122, 14, 124, 65 and 67. So head starts at 53. So now we are already in 53rd position. From 53, the scan algorithm should move towards other end. So now from 53, supposed to move to 37 and then 14. So towards left because supposed to move towards other end. So 37 and 14 has been served. Then you can't take U-turn here. Supposed to move to the entire end, dead point, end point. So end point is 0 now. So in that particular position, 0th position, please follow my cursor. In 0th position, it will take a U-turn here. Then supposed to return to the other end towards right 199 side. So while serving on that direction, it will serve all those schedules. Disk scheduling this has been served. So 53, then 37 has been scheduled, then 14 has been scheduled. Then take U-turn in 0th position or end point. in the left hand side. Then after taking U-turn, supposed to move to the other end. So while moving other end, serve all those remaining in that order. 65, 67, 98, 120 has been served, 120 has been scheduled, 183. So now if you have entries, say 50, then you can't take U-turn here. Supposed to visit to the other end, 199. Then take U-turn and come back. Then serve 50. That is how scan algorithm works. So any doubt or any clarification, please ask. One thing is supposed to notice, say consider as a demerit or a drawback in this particular scan algorithm is based on the direction of head, it's supposed to serve towards other end. Say 53 is already in this, so it's supposed to serve in towards left. So now while serving 37 and 14, while scheduling 37 and 14, so all these other requests from the other side supposed to wait till it gets served, till it gets scheduled. So that's why there may be having longest waiting period. So according to this particular situation, 183 will be having largest waiting time because it has been served at the end according to this particular example. Okay, so moving further, C scan. This is update with the scan algorithm. It will provide a uniform wait time than scan. So we are trying to avoid that largest waiting time or longest waiting time. So now here it says the head moves from one end of the disk to the other, servicing request as it goes. So it should move from one end to other, servicing request as it goes. And when it reaches the other end, however, it immediately returns to the beginning of the disk without servicing any request on the return trip. So please, this is a very important point. Please have a look. When it reaches the other end, however, it immediately returns to the beginning of the disk. So while returning, it won't serve anything. So now, so treats the cylinders as a circular list that wraps around from the last cylinder to the first one. So now we'll see an example, then you can understand. We'll come back to this particular question part later. So we have a C scan, a little bit updated version. So it says, so the head moves towards the other end. While moving, it will serve all those, whichever the schedule comes first, comes in that particular direction and returns from that particular end. It moves to the end, take U-turn and come back to the end. And while returning, it won't serve anything. It won't provide any scheduling. Again, to start from the beginning, 0. So now, head starts from 53. From 53, it's supposed to move to the other end. So now, while moving other end till 199, it is supposed to serve 65 first, 67 first, second, then 98, then 122, 124, 183. So according to the list, whatever the queue list we have, queue entries we have, so 183 is the last one. But here it can't take a U-turn. It's supposed to move to the other end only, 199. Then it's supposed to take a U-turn or reverse and come back to the original initial position, that is 0. From that 0th position, next should be scheduled, that is 14 and 37. That is how C scan works. So the difference between C scan and scan algorithm is, with respect to scan algorithm, it will follow the staircase and it will take a U-turn when it reaches the other end, right? So now in this case, it won't take U-turn over here. So it will take a U-turn, then again comes back to the initial position, that is 0th position. So each and every time, whenever we get a scheduling value, disk request, it has to return to the original position. Then only it can take the next schedule. So now one thing is supposed to observe, while returning, it won't serve anything. It will keep blank. It won't serve anything. It will be idle. So for this one, we can give a real-time example. Say courier service. For example, you are trying to buy a product from Flipkart. The say product may be originated from say Gurgaon. So from Gurgaon to Mangalore. So the product has been traveling on the road via courier service. with the using a lorry. So lorry driver's job is to deliver that particular product to you. So he'll pick up that particular product from Gurgaon and he'll keep on driving from Gurgaon to Mangalore. So he reached Mangalore. Please follow my cursor as well. So he started from Gurgaon, say 53 is a Gurgaon. From 53, he's supposed to pick some other products on the way, and he reached Mangalore 199, sorry 183. So you deliver it delivered. So now your location may be in say Udupi. So Udupi is served over here, but it can't take U-turn. The lorry cannot take U-turn in that particular direction. Should come to the Mangalore city and take a U-turn over here. So while returning back to the Gurgaon, it won't serve anything. It won't pick up anything. It will ride in a blank container or empty container. The lorry will be empty. So that is why on reverse, it won't serve anything, any schedule. It won't serve any schedules. It won't serve the disks. That is how C-scan works. So now the question is, if we have more number of cylinders are nothing but in a disk, all the platters are be stored in a cylinder. Each platter will have number of tracks. Each track will have number of sectors. Consider for each and every time, say you started from second platter, then if you want to have any search information, if you want to search anything on the disk, then you're supposed to search for till the nth cylinder or 100th cylinder, then you're supposed to come back and check with 0th and first cylinder. So now it may take much time if the data is already available in 0th disk, right? So that is based on the cylinder, it may take much time. So that is one of the disadvantage in this case in this type of C-scan algorithm. Moving further, so we have a C-look. It is a look version of a scan and C-scan. So scan and C-scan. Scan is nothing but elevator or staircase. C-scan, it will take U-turn on the other end and starts from another end. So how it works? Arm only goes as far as the last request in each direction, then reverses direction immediately. Arm only goes as far as the last request in each direction, then reverses direction immediately without first going all the way to the end of the disk. Arm only goes as far as the last request in each direction. So now consider, so we have a situation supposed to serve for around say 5 to 6 IO request from one direction. So it will serve all those in that particular direction from left to right. And whenever it reaches the last point, then it will take a reverse direction. And while reversing also, it will serve all those, whatever remaining. So we'll see an example. So now with the queue, so we have 98, 183, 37, 122, 14, and these are the IO request has been made. So now disk head is in a position 53. So from 53 it should move, it should serve all those whichever comes in this particular list. On the other hand, for an easier exercise, we can say supposed to list sort these numbers in ascending order. Start from 53, move towards ascending order is move towards top. To serve all those 65, 67, 98, 120, 124, and 183. That is the easiest way for a better understanding. And take U-turn in 183 and come back to 14. So next to 14 is remaining 14 and 37. So that is on the tail end. Supposed to come back to the tail end, that is 14. Then 37 has been served. That is how C-look works. So now the difference is with respect to previous C-scan, the difference is it won't go till the end. It won't go till 199. So it will take U-turn wherever it has been stopped. That is 183. That is the last value. Last IO request has been made. Then coming back to the initial position. So according to the list, initial position is 14. There is a least value. that has been served, then 37. So if you got 60, say 75, then from here it moves to 75th location. Then if you got 20, take U-turn here only in 75th position and come back to 20. That is how C-look works. So we have covered some of the algorithms. First come first serve. That is first come first serve is based on the entries in that queue. It has been served. First come first serve. Whichever comes first, that has been served. SSTF, it will serve shortest, whoever is having shortest seek time, that has been served. Then scan algorithm, it will serve all those which comes in the direction. Head starts from initial position. Say if it is 53 in this particular example, then moves towards left till reach the initial point, that is 0 on the other end. Then it will serve the reverse direction while returning, or while serving on the other side, it will serve all those whichever comes in that particular lane. C scan, it is a little bit advancement with this scan algorithm. Over here, it will move till the end point on the other side, take U-turn, it won't serve any other IO request while returning, and again starts from 0th position. Coming to C look, with respect to C look, again it will serve all those IO requests which comes in that particular line and takes U-turn the last IO request, that is 183, and again it won't serve any of the IO request while returning, and it will come to the least point, that is initial least IO request, that is say 14 according to this particular example, that has been served, and then move to 37. So that is how the C look works. So these are the 5 important algorithms. Please go through with this. Very, very important. Very, very important. Please practice. However, we shared some of the exercises. Please solve all those. Okay. So if you have any other clarification, any doubt, please get back to me.